Welcome to lecture 1 and lecture 2, where we're going to look at descriptive statistics. Descriptive statistics is very important that we, as statisticians, as managers, we need to be able to identify the interpretation of numbers. So we deal with numbers on a daily basis, how to present data in different kinds of presentations. It can be through pictograms that you may call histograms, pictograms that you may call bar charts, pictograms that you may call frequency polygons. So all these will require you to understand the concept of descriptive statistics. Now, before I meddle into the calculations of any sort, I'll perhaps take you through a few key principles, descriptive principles in statistics. So we need to understand what qualitative data is and what quantitative data is. So anyone to help me understand the difference or the definitions of quantitative data and qualitative data in your own understanding. What is quantitative data and what is qualitative data? Yes, Makungu, what is quantitative data and what is qualitative data? This is our starting point.
Quantitative data is, I think, data that will enable us to use figures.
Okay. Quantitative data, yes, you find figures. And what is qualitative data then? Anyone to try? That is important for us to really start with. Quantitative data, she says, is data that we use when we are quantifying information, whereas qualitative data is mainly about the quality of the information. It looks at information that is non-measurable. It's descriptive in nature. So that being the case, we're now going to delve in examples of quantitative and qualitative data. So when you're dealing with quantitative data, we're looking at measurable data. So we can have quantitative data. Please mute yourselves. That is discrete. And we can have quantitative data that is continuous. So we have what is called discrete data under quantitative. And we also have what we have, which is continuous data. When we're dealing with discrete, we're looking at data that you cannot, it's definite, in short. It hasn't got any decimal points. Discrete data is simply data that doesn't have integers, the whole numbers, in short. For instance, you're dealing with the number of classes you had, the number of children that you have. You can't have 1.5 children. You're dealing with statistics to do with the frequencies of your operand. How many times you go to class? Okay. So it can either be 3 times, 4 times. So this is what non-interval data. This is called discrete data, where you have countable numbers 1, 2, 3, 4, etc. When we're dealing with continuous data, we're looking at interval data, or integers in short. They could be fractions, they have decimal points. For instance, we're dealing with the weight, we're dealing with time, you're dealing with height, you can have data that is 1.2, 1.5, okay, kgs, the height maybe are 2.7. This is what we call continuous. You can also use this in terms of the volume, okay, of liquids. This is what quantitative data, but under continuous. So quantitative, we're looking at what? Numeric data. Then on the other hand, we also have what we call qualitative data, which has to do with quality or descriptives. So under qualitative data, we can indulge in what we call nominal data and ordinal. So these ones are quite synonymous, where ordinal and nominal can also tally with discrete and continuous. When you're dealing with our nominal data, we're looking for categorical data. For instance, you place of birth, you're either born in Zambia or Zimbabwe. Okay, you're either male or female. You can't be both. But we also have ordinal data that can overlap. For instance, tribe. It can be half Bemba, half Tonga. It can be a mixed race or colored, although they don't like being called so. It has an intersection, all right? So this kind of data is very important for you to categorize it in its right context. Are we together so far?
Yes, we are.
Hey.
Yes, Mr. Collins.
We will also need in this course understand some pictograms. So pictograms are very important as statisticians so that you're able to present the data in what people can relate to. For instance, we have polygons that look like this. They have a special name. We also have polygons that look like this. A special name. We also have polygons that intersect these figures and the midpoints. So you have a line that will join this point and that point and that point. Okay, we also have graphs that are upsloping, they never fall down. We also have graphs that are zigzag. Okay, we also have graphs that will take up this format. So when you see these ones, you need to know what they are and what they stand for. We also have graphs that look like this. So at least you can be able to identify any of these from your elementary information. So graph number A is what? Graph B is what? C, D, E, F, and G. Please identify any one of these pictograms. Anyone? What can you identify? Yes, Chris. So A is called a what? Makung, what is A? The bar chart. Are you able to hear me? B is a histogram.
Yes, we can hear you.
The difference is that one has gaps in between and one is continuous. So this one is what? Discrete. This one is continuous. Then we also have this line that joins the midpoints of this histogram, which is called an ogive. Then we have a cumulative frequency polygon. So this one is accumulating, it's not falling down. That's why we call it cumulative, it accumulates. Then we have what we call a frequency polygon. It can also be a relative frequency polygon. This one is just frequency because it can fall down. Cumulative doesn't fall, it always accumulates. Okay, so frequency graph, if you want. Then this is what we call our box and whisker plot. It is very essential to identify what we call an outlier. I'll explain that later on. But for just identifying the box, it's called a box whisker plot. We also have what is called a pie chart. And this is what we call a stem and leaf diagram. So these ones are important for our course because they will help us and guide us in a lot of things that we are yet to find out. All right, so quickly, let's get to some exam type questions before we proceed in anything. So we have information that we have here where we're asked to consider the following statements. We need to either state whether they're discrete or continuous under quantitative, or they are ordinal or nominal. For instance, the weight of a baby in kilograms. What kind of data is this? This is what? Quantitative, because it's measurable. But besides it being quantitative, it has decimals. So it is what? Continuous data, which is interval. There's interval, there's ratio, there's area, but I'm just interested in these two. It is quantitative because weight is what? Measurable. It is continuous because it has decimal point. You have 2.3, 2.5. It's a continuous kind of data. Intervals is because you can be measured in terms of obese or underweight. It has certain categories. Then we are told, but B, which country were you born in? So I said, this is what? Qualitative. You can't measure it, it's quantitative. It's qualitative. But it's either ordinal or nominal. So you're either born in Zambia or Zimbabwe. So it is what? A kind of nominal data. So for each day, the difference between the maximum and the minimum temperature. So already we're able to calculate this temperature using a thermometer. So this is quantitative data. But it's a continuous data that can be in intervals, can be cold, melting point, boiling point. So it's temperature that is in a continuous form. For each member of the national team, their total number of appearances at the Africa Cup. So you can count the number of times. So these ones are quantitative, but discrete. You can't say we have appeared at the national Africa Cup 2.5 times. All right, it's either a 2 or a 3. Are we together so far on the types of data and how the questions come in that context?
Yes.
Then we go in now identifying what we call frequency distribution polygon. So we are given information below. So let me take it to my clipboard so that we can relate to it very well. So in this case, we want to know how to group data. So in this case, we've been told that there are 20 students that have been enrolled and their major courses are as follows. So we have the following courses. We have what? Spanish. What other subjects do we have? We have French. What else?
Italian.
Italian, yes.
German.
German, yes.
Russian.
Russian. Anything else?
No.
Nothing else. Yeah? So let's count how many are Spanish. We can use black. Let's count them there. 1, 2, 3, 4, and 5. So you can use a tally if you want. So you have 1, 2, 3, 4, 5. So what is the frequency for this one? Yeah, 5, right? And let's go to the other one. It's French. How many are they? 1, 2, 3, 3. 1, 2, 3. So these ones are 3. Let's go to the other tribe, the other language. What do we have? Italian. 1, 2. We have 1, 2. We have a 2 there. Let's go to the other one. German. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So we have 7. In Russian, so the Russian, can use black again. How many are they? 1, 2, 3. What? 1, 2, 3. So it is 3. All right, so far are we together?
Yes.
In total up, they should be 20 in total. All right, so you can cumulate them. It should also be 20 as the last number here if you've counted very well. So we bring here 5 plus 3, 8 plus 2,
10.
10 plus 7, 17 plus 3, 20. So this is our 20. It should tally here. This is 20. This 20 must be good, that 20 there. Are we together? So this is what we call a frequency distribution table. This is where it ends. Now, sometimes I would ask you to add 2 more things: the relative frequency table and the relative cumulative frequency table. All right. So simply dividing this answer in there. So 5 divided by 20. What do we get? 0.25. 8 divided by 20. 0.15. 2 divided by 20. 0.10. 7 divided by 20. 0.35. 3 divided by 20. 0.15. You total this up, should give you 1. So this is also called the probability of the distribution table. This is called the relative frequency table. Then we can have the relative cumulative frequency as we were doing here. This number comes there. The total must be, no, the last number, not the total. You don't add the cumulative total. The last number must be 1 or 100%. So you bring this one here, 0.25. Then you add 0.25 plus 0.15, what do we get? 0.4. 0.4 plus 0.1, what do we get? 0.50. 0.50 plus 0.35, what do we get? 0.85. 0.85 plus 0.15, what do we get? 1.00. So this is what we call a relative cumulative frequency. Are we following together?
Mr. Collins,
Yes, sir.
how did you find the 0.10? Because I thought it's 10 divided by 20. I don't know if I'm, or how is it going? Or it's 10 over 20?
Which one are you talking about now?
The relative frequency, the 0.1.
This one?
Yes.
We're dividing this over that because we're using this column. 5 divided by 20, 0.25. 3 divided by 20, 0.15. 2 divided by 20, 0.1. 7 divided by 20, 0.35. 3 divided by 20, 0.15. So when you divide on a calculator, 2 divided by 20, you get 0.1.
So in short, we're dividing 20 into the small numbers, not the
Yes.
small numbers into 20.
Yeah, divide relative frequency, dividing this in there. So this one was what? 5 over 20. This one was what? 3 over 20. This one was 2 over 20. This was 7 over 20. This was 3 over 20. So that's how we're finding these figures here. Is that clear?
Yeah. You're recording, Mr. Collins, huh?
Yes.
Yeah,
Right.
I want to go through it after we are done.
Any other questions so far?
Okay, maybe just go through how to do the relative cumulative frequency again. Maybe just one part.
Relative frequency, you can do it in two ways. You take this guy there, you said add 0.25 plus 0.15, 0.4. 0.4 plus 0.1 is 0.5. 0.5 plus 0.35 is 0.85. 0.85 plus 0.15 is 1.00. Or you divide 20 divided by 21, 17 divided by 20 is 0.85, 10 divided by 20 is 0.5, 8 divided by 20 is 0.4, 5 divided by 20 is 0.25, either of them.
Okay, thank you. The addition seems much easier.
Yes, addition is a lot way easier. Okay, so I'm taking you like babies. Where you're behind, please tell me. Are we together so far?
So far, so
Yes,
good.
we are.
All right. So now I will take you through another important table of summary. So you have 0, 2, 0, 2, 0, 4.
Mr. Collins, sir.
Yes, sir.
There's part number 2, which was saying make a frequency histogram.
Oh, okay. Yeah. Before I get that, yes, thank you. So a frequency histogram, basically, remember how histograms looks like. So I'll use the letters S for Spanish, F for French, Italian is I, German is G, and Russian is R. For these ones, we want to draw the histogram. So we have 1, 2, 3, 4, 5, 6, 7 as the highest number. So these are the frequencies. So for Spanish, what was the frequency? 1, 2, 3, 4, 5, 6, 7. Plus 5. So we go here. 5. Okay. So that is a 5 there. Then for French, it was 3. So you go to 3, it is a 3 there. For Italian, it is a 2. 2, that is a 2 there. For German, it is 7. 7, that is there. For Russian, it's a 3. 3, that is there. So remember, this was my introductory part to say histogram, they're usually attached to each other there. So you can have your what? 5 there, 3, 2, 7, and what? 3. So this is how the histogram looks like. You need to give it the title histogram. And here we have what? The language. So this is how we draw our histogram. Okay. So we now need to learn how to draw a stem and leaf diagram. So if you're given a stem and leaf diagram, which looks like this. Okay, so here we have 15, 10, 10, 4, 16. Here we have 20, 22, 24, 21, 22, 25, 25. We have 42, 41, 40. We have 53. So we're being asked to draw a stem and leaf diagram using this. So the smallest number starts with a 0. So you put a 0 there. That is called a stem. The last number is called the leaf. So we have a 0, 2. Then we have the last number is a 50. So we have zeros, ones, 20s, 30s, 40s, and 50s. So we need to arrange in order of ascending. So for the zeros, the 0, 2. So since it's already a starting number, so just put a 2 there, 0, 2. The next number is what? Another 2, 0, 2. So you put a 2. The next number is what? 0, 4. You put a 4. And the last number is 0, 5. For the zeros, we are done. For the tens, the smallest number is 10. So 1, 0. Then we have 1, 0 again. So we have 2 tens. Then we have 1, 2. So this is 12. Then here we have, on the ones, which one else is there?
1, 5.
5, yes. What else is there?
6.
1, 6, correct. On the 20s, what numbers we have?
20,
2, 0.
0,
Then
1,
1, which is 2, 1, correct. Then
2,
22, yes.
another 2,
Another 22, so 2, 2, yes. Then
4, 24,
24, yes. Then
and 25,
25, correct. Then
another 25.
another 25, correct. The 30s, we don't have, so we leave it. Don't put a 0 there. And then you make it 30. So 30s is nothing, but it's supposed to be in order. You leave it as a number. So the 30s is nothing. 40s,
40, so 0,
40s, we have 40 itself, so 40, yes. Then
41,
41, yes.
and 42.
42, correct. And the 50s,
I have
53. So this is how we draw the stem and leaf diagram. Stem
Mr. Cole,
and leaf diagram. Yes, sir.
I think I was just a bit behind it. How are we coming up with these numbers? I think I've missed one point.
So let me go through this for those
Okay.
who did. So stem and leaf is just a summary of the figures that you have in ascending order. So you're giving data here with the smallest number, which is 0, 2, and the highest number is 53. So you look for the hub, which is the stem, the numbers that you're starting with. So if you have numbers like what? 10, we have numbers like 102, we have numbers with 115, we have numbers 205. So the last number is a leaf. So here, if you're using the stem, so for this kind of a number, it is 10. For this kind of a number, the last number is a 2. So here it is 10 and a 2 at the end. So this 2 is your leaf. About this number, it's 11 and a what? 5. Then this number is a 20 and 5. So this is how we draw a stem and leaf diagram. So in this case, we only have 2-digit numbers here. So 0, 2, 1 zeros, 20s, 40s, and 50s. So for zeros, so yeah, we have 4 numbers that have 0. So instead of writing 0, 2, 0, 2, 0, 4, they already all have a 0. So this is 0, 2, this is 0, 2, this is 0, 4, and 0, 5. We are arranging them in order. Fortunately, they're already in ascending order. For the tens, we have 10. So 1, 0, this is a 10. Another 1, 0, 10. Then we have a 12. So 1, 2, 1, 5, this is 15, and this is 16. So we are done with the tens. The 20s, we have 2, 0, which is a 0, 2, which is 21, this is 21, 2, 2, 22, and 22, and 2, 4, 24, 25, 25. Then the 30s is nothing, so you don't put anything there. The 40s are 4, 0, 4, 1, and 4, 2. And the 50s are 53. So this is in a nutshell how we write a stem and leaf diagram. Is that clear? You get it now?
Yes, we do.
All right. So On top of that, you can also learn how to come up with what we call our frequency distribution table. So in this case here, you can come up with a class width. For instance, this is 0 to 9, and this is 10 to 19. And we have what? 22, 29, 30 to 39, 40 to 49, and 50 to 59. So how many numbers are between 0 and 9? The frequency is how many? 1, 2, 3, 4. So here the frequency is 4. We'll put 4 on the frequency. How many are between 10 and the 19? So these are 10s. I mean, the 1, 2, 3, 4, 5. So they're 5 there. How many are between 20 and 29? 1, 2, 3, 4, 5, 6, 7. You put a 7 there. How many are between 30 and 39? 0. There's none. How many are in the 40s? So 40 to 49, how many are they? We have 3. And how many are between 50 and 59? We only have one number, which is 1. So you're summarizing this data. Then I also taught you how to come up with a cumulative frequency. So you bring the 4 here. 4 plus what? 5 at 9. 9 plus 7, 16. 16 plus 0, 16. 16 plus 3, 19. And 19 plus 1 is 20. So this is what we call a frequency distribution table of summarizing this data. We can summarize the data based on the combination of the data that we've been learning together. So this is what we call grouped data. This is how we group the data. Now, let me look at simple figures. 2, 4, 4, 8, 5, 5, 10. So this is what we call ungrouped data. Please, the first class is free. Invite your friends so that they don't miss out. The first thing you need to do is ungroup data to rearrange it in ascending order. So let's arrange it from the smallest to the biggest. What is the smallest number here?
2.
2, then
4.
4, then
4.
then
5.
then
5.
then
8.
then
10.
how many are there in total? 1, 2, 3, 4, 5, 6, 7. So our n is what? Number of observations 7. Okay. So from this data, which we call ungrouped, we can find 10 measures of central tendency and dispersion. The easiest one is a range. The range is simply the difference between the highest number and the smallest number. So what's the highest number here?
10.
Yeah, the smallest number.
2.
So the range is 8. The mode is the number that appears.
Mr.
Yes, please.
I'm sorry, my brother. I've just been called by my boss. I can join me later. I hope you can post this as soon as we are done. I've just been called now. I need to report to take some reports.
Okay, no problem. All
okay,
right.
my brother.
So here we are getting the difference between the highest number and the smallest number. So 10 minus 2, we get 8. That's how we find the range. Is that clear? And the
Yes.
mode is the most frequent number, the most frequent polygon. So what number appears the most here? 4 and what?
And 5.
5.
5. Yeah, so those ones denote our mode. All right. Then we get to what is called the quartiles. So we have quartile 1, which is a quarter of n. We have quartile 2, which is half of n. And quartile 3, which is what? 3/4 of n. So our n is 7. What is a quarter of 7? So the rule here is if the number is a continuous figure, what I mean is if it's got a decimal, you round up. If it's a whole number, you add that number and the next number, you average them too. So what is a quarter of 7?
1.
Pardon? What is a quarter of 7?
1.
1.75.
7, 5.
1.75. So I said you round up,
Round off.
so it will give us the what? Second figure. So what is the second figure? If we are to check here, this is 1, 2, 3, 4, 5, 6, 7. The second position here is what? 4. What is half of 7? Since our n is 7, what is half of 7? 3.5. So you round up. Whether you have 3.1, 3.2, 3.9, as long as the decimal point, you round up. So this would be the fourth position. So what is the fourth position here? Fourth position is what? 5. So our Q2, sorry, is what? 5. So this is what we call the second.
Mr. Collins, just a question. I
Huh?
think I'm a bit confused on how we're rounding up.
So rounding up, I said, as long as it's a decimal point, whether it's 3.1, don't round off to the nearest whole number, no, just round up. Whether there's a decimal point, as long as it's a decimal point, you round up. Of course, there are books that use another formula. When you have +1 there, you round to the nearest whole number, but here, I'm using the actual n, so you round up. It's the easier formula. So you're rounding up. So here, since I
So we're using n. In this case, our n is 7. So how are we rounding up to
1.7.
1.75?
So I said whenever there's a point there, you round up to the nearest number. So since it's 1, what is the next number up? It's 2. All right?
Yes.
Whether we are at 1.1, rounding up this one is the same as 2, as long as the difference. How about if you're at 7.9? This is 8. How about 7.11? Still 8, as long as there's decimal
Oh,
point.
so you go to your table and get the second
Then
second
yes, the
number
second
at
position,
Q1.
yes. Yes, so the
Second
second
position.
2. So this is a position. So the second position, the number is what? 4. That's how we get the 4. Then here we go 3.5, we rounded up the fourth number. So 1, 2, 3, 4. The fourth number is what? 5. So those are just positions, but the actual answer is when you count them after rearranging them in order. Is that clear?
Yes.
So here 3/4 of 4, what do we get? 3/4 of 7, sorry. 5.25. So what do we get when we round up?
Is it the 6th position?
6th position. So what is the 6th position there?
8.
Good. That is our 8. All right. So now we have the quartiles, the upper quartile, the lower quartile, 4, 5, and 8. Our lower quartile was what? 4. Our second quartile, which is also called the median, is 5. And our upper quartile, or the third quartile, is called 8, or Q3. Then the smallest
So
number.
would you call the Sorry. Would you call the first quartile mean?
No. It's not the mean.
Oh, okay.
It's the second
Because I
quartile.
heard you call the second one the median
Yes, this is the median.
because it's just a median number.
Yes. So this is the first quartile.
Okay.
This is the second quartile. And this is what? Third quartile or upper quartile. Okay, then we also had the smallest value of x was 2. What was the smallest value of x? 2, and the highest value of x, 10. So minimum value of x was what? 2. Maximum value of x was what? 10. So the difference between the smallest number and the upper number is called the range, except that for the values of x, this is just the range. 10 minus what? 2 is called the range. Okay? But the difference between the quartiles is called an interquartile range. So 8 minus what? 4 is called the interquartile. All of them are ranges, but this one is called what? Interquartile range, because the range to do with the quartiles. So we have a 4 there. So using these values of the ranges, we can come up with a box-whisker plot, which has 5 important things. The minimum value of x, number 1, and the maximum value of x, and the quartile 1, quartile 2, and quartile 3. So what was the minimum value? It was 2. Maximum value is 8. The quartile 1 was 4. Quartile 2 is 5. And quartile...
Sorry, the maximum value should have been 10, wasn't it?
It's 10, thank you. 10. So here it is 10. So this is how we draw a box-whisker plot. All right, the quartile range was what? 4. And the correction term is simply when you multiply the interquartile range times 1.5. So 1.5 is the standard value. So you multiply it to the interquartile range, you get what we call the correction term. So 1.5 times 4, we get a 6. So this is helpful to identifying the outliers. So it's like you're giving additional probationary time. So if we're supposed to close at 10 minutes, so we're going to add 8 plus 10, 8 plus the correction term, this is a correction factor. 8 plus 6, we get what? 14. So meaning this 10 is within, it is within range. Then from the 4, we subtract the correction term. 4 minus 6 is negative 2. So negative 2 is this side. So meaning we have closed the doors here. Anything outside that is called an outlier. So if our numbers were going up to maybe 20, then 20 is outside here. So we would have said 20 is an outlier because it's outside the probation. So these are the extreme values that are important. So this is an important skill you need to understand when you're dealing with what we call our stem leaf, our box-whisker plot. Okay. So let's go to our tests paper. Unless there are any questions so far. Okay. So we can go to our test paper. So we're going to look at questions to do with statistics. Maybe before I go there, I could also explain the measures of central tendency and dispersion. So if you have numbers like values of x, we have 2, 4, 6. So you can square them. What is 2 times 2? 4. 4 times 4, 16. 6 times 6, 36. All right, so when you add these ones up, this is summation of x, the 12. When you add this part, what we get? summation of x squared, which is 56. What is our n? How many numbers are here? Our n is 3. So you can find the mean as follows. The mean is simply found by the formula summation of x over n. So our summation of x is 12, our n is 3. What is our mean in this case? 4. So 12 over 3, we get a 4. Then we also have what we call the variance. So the variance is given by the formula s squared is equal to summation of x minus summation of x to the power 2 over n. Everything over n minus 1. So what is our summation of x squared? 56. What is summation of x? 12. And what is our n? 3. Everything over 3 minus 1. Okay. So far in substituting those issues there, are we all together?
Sorry, Collins. I had received a call that I just quickly cut off, but I am just trying to understand how we got to the variances.
Okay, first, are we okay with the summary data? Summation of x is 12. We got it. Summation of x squared is 56, and our n is 3. Are we okay with these ones?
I'm okay with the x squared, but the n being 3.
1, 2, 3, the number of observations.
Okay.
Mm.
Okay, yes, I get that one.
Okay, so after getting that, we now use the formula here. Summation of x squared, it's a big number, don't put a small one, so the big number, 56 here. Summation of x to the power 2, so these two are different. Summation of x squared, the summation of x to the power 2. So 12 to the power 2. Divided by n is 3, then n minus 1. So you start from here. What is 12 squared? 144. Okay. What is 144 divided by 3? 48. So you have 56 minus 14. Then 3 minus 2, 3 minus 1 is 2. So now we subtract. 48 minus from 56, we get 8. 8, what do we get? 2 into 8, what do we get? It's a 4, right? So the variance is 4. Then standard deviation is always the square root of the variance. So variance is s squared, standard deviation is just s. We square root what? Our variance. So the square root of 4 is what? 2. All right. So that is how we find our standard deviation, the mean. And lastly, how to find the coefficient of variation, or denoted as what? CV. Coefficient of variation is simply found by standard deviation over the mean times 100. So what was our standard deviation? We just calculated those 2, the square root of what? Of 4. This is our standard deviation, our S2. And our mean was 4. So our mean is 4 times 100. So what is 2 divided by 4 times 100? You get 50%. So this is what we call our coefficient of variation, or CV. Then we can also find our coefficient of skewness. Skewness just tells you the bending, whether it's bending to the right or it's bending to the left. So the formula is 3 x bar minus median over what? Over standard deviation. So our median, our mean is what? Is 4. Our standard deviation is 2. Our median is a number in the middle. Since I already rearranged it order, which number is in the middle? 2, 4, 6. Which one is in the middle? 4, right?
Sure.
So 4 is a median. So 4 minus 4 is 0. 0 times 3 is 0. 0 over 2 is 0. So if our coefficient of skewness is 0, it means it is normally distributed. It's 50-50. The left side and the right side is equal. So what skewness does, if you got, for instance, negative 0.2, you would say that our distribution is negatively skewed, meaning a lot of people may be failed if we're dealing with a pass mark. Or if you're dealing with the gender between male and females on the left and the males on the right. So if it's skewed to the left, it means you have more females than males. If it's skewed to the right, you have more males than females. So you had positive 0.2, for instance. But if you go to 0, it means it's packet. We have equal males and equal females. So a distribution is normally distributed with the mean is equal to the median is equal to the mode. If all these are unequal, it means it is normally distributed. It is a normally distributed distribution. So you need to understand how to calculate all these that I've mentioned. How do you find the median? It is a middle number. If you're using the formula, we're at 3, we're at 2, 4, 6. Remember the formula for the median? It says median is what? Half of n. So n here is, there are 3 numbers there. So half of what? 3 is what? 1.5. So 1.5 you round up. So it's the second as the second position. So if you look here, what is the second position? It is 4. But by looking, median means the middle. So the middle number here, if you arrange them, is 4. So you don't even need to use the formulas if you like. So this is how the formula is supposed to be. You are given formulas. Some schools you're not given formulas, so you need to understand basically. Yeah. So this is basically on descriptive statistics, grouped data and ungrouped data. So we've done the first segment, which is what we call ungrouped data, how to find the mean, median, the mode, how to draw the stem and leaf diagram. So let me quickly take you to the test that was written by your colleagues. So in this test, I need you to figure out 1 or 2 things that I have just made mention of. So I'll just relate to questions. Most of the questions now come like quizzes. So this is on probability. I'll not look at it today, perhaps during the week. So this one is to do with what? Statistics. So they ask you to calculate the mean, the median. Who remembers the formula for the mean? Who remembers the formula for the mean?
Summation of x over n.
Good. Summation of x over n. So we literally needed to do what? To add all these here. Now n is 16 already. So n is 16. All right. So summation of x means you're adding all these figures there. So if you add the figures there, you're going to get 500 and what? 544 or 545. So you just divide 545 divided by 16. You find yourself getting 34.06, which we found here. But how do you find the median? you first rearrange. You cannot find the middle number here, but you rearrange them. Okay. So now on the median, I forgot to mention one important thing. So if you're given numbers, for instance, like 2, 4, 6, 8, our n here is what? 4. So we want to find the quartile 1, quartile 2, and quartile 3. So this is a whole number, a quarter of n. So what is a quarter of n? So a quarter of 4, n is 4. A quarter of 4 is what? 1. So if you have a whole number, exactly, you get that number and the second number and divide by 2. So 1 here, so you get the first number and the what? The second number. And you average them, divide by 2. So our first number is 2. So 2 plus 4 is what? 6. 6 divided by 2, what do we get? 3. So our first quarter is 3. Then we go to the second quarter. Second quarter is half of n. So half of 4 is 2. So when you have a whole number 2, it means get that number, the second number itself, and the following number that follows, and the third number divided by 2. So which one is the second number? This one here. And the third number, this one there. So 4 plus what? Plus 6 divided by 2. So 10. 10 divided by 2 is 5. So 5 is our second quarter, or the median. Then again, we go to the third quarter. 3 quarters of what? N. So 3 quarters of 4. What do we get? 3 quarters of 4. We get 3. So this means that the third number and the fourth number divided by 2. So third number is 6 plus 8 divided by what? 2. So 14 divided by 2, what do we get? 7. So 7 is our what? Our upper quarter. So I'm trying to take you to how to approach this one here. So we have 16 numbers there. You first rearrange them in order. Once you rearrange them in order, our median, which is the second quarter, is half of n. So half of n is half of 16, meaning the 8th number. So what does it mean if you get exactly 8? Which numbers are you averaging? The 8th number.
8th number and one that follows.
The 9th number, correct? Then you divide by what? By 2.
By 2.
So in this case, the 8th number was 37, and the 9th number was 38. When you divide by 2, you're going to get the 7.5, which we found here. So you need to take your time. Yeah. So we also go here in the graph. So we asked, what is this type of graph? Is it a bar chart or is it a histogram? Pardon? It's a histogram because it is attached. Histogram is attached, bar chart has spaces, so it's a histogram. Then find the number of students with a height between 135 and 140. So 135 is here and 140 is there. So what is the height there? 20. That's where 20 is coming from. So this data is used to present quantitative data. Is that true or false? It is true. We can measure the data. So true. Okay. Then here we've been given a 16-page manuscript. So we've been given the following frequencies. So we are being asked to classify them in intervals. So 26, 24 to 26, 26 to 29. So you can see here there's a 26 repeating here and here. So don't count 26 in the first, just look at 24 and 25, 27, 28, 29, 30, and 31. That's the tricky part on there. So if you're going to look at here, which numbers are between 24 and 25. So you go here, you discover that there's only 2 numbers. 25, 25, there are 2 here. Which one are between 26 and 7? There are 8. 1, 2, 3, 4, 5, 6, 7, 8. Then between 28 and 29, there are 4. 1, 2, 3, 4. And 31 and 32, 31 and 32. So we have 31 there. Oh, 30 and 31, sorry. And 30. There are two there. So how did you find the cumulative frequency? We add the 2 comes there. 2 plus 8, 10. 10 plus 14. 14 plus 2, 16. Remember how we get this, yeah? Then the total is going to be 16. Can somebody remind me, how are we getting these figures there?
We divide the 16 into the cumulative frequency. So 2 by 16, 2 divided by 16 to get that.
So we divide 16 in each of them. So 16 divided by 2, 8 divided by 2, 4 divided by 2, and that. Is that correct? Is she right?
Yes, she is.
All right, so this is how this figure is supposed to be gotten. Then also we're given the scenario of this. How do you find the mean? How do you find the standard deviation? So I showed you the formulas for it. All right. Isn't this easy? Understandable. Then here we're told to draw a stem and leaf diagram for this data here. So we have the numbers start with 40 and the last number is 90 something. So you put 4, 5, 6, 7, 8, 9. So for the 40s, we have 40, which is 1, and 49. So 40 and 49. For the 50s, we have 53, which is that one. Then 55 and another 55. So this one is out because it's only giving us 155. So this one is so far okay. The 60s, we have 60. So you need to put a 0 here. So this one is wrong again. This one is wrong because there's no 0 there. Okay. So 60, this one seems to be right. There's a 0 there. Then we go to 70 what? On the 70s of 76 and 79. 76, 79. And the 80s, we have what? 85 and 87. So 85 and 87. And 90s, we have 91 and 99. So this one is okay, except just that part and that part. So you see how to come up with the stem and leaf diagram. Are we clear?
Yes, we are.
Yeah. So here you're asked to come up with what is called a cumulative frequency table with the intervals. So the class width that you have here, what's the class width? Find the class width, just find the difference between this and that, this and that, this and that. So what is the class width? 5. So the class width is 5. Or height. It's better to look at it from this to that, not this to that. Sometimes this one will deceive you. So the difference from here downwards or this one upwards, it's a class width. The frequency you look here, how many are there between 40 and 44? There are 2. 45 and 49, you go on and on. Then the cumulative frequency, you put this number there, 2 plus 6, 8, 8 plus 13, 21, 21 plus 12, 33, 33 plus 7, 40, 40 plus 2, 43. So this is what I was just explaining. As easy as that. So also you'll be asked to calculate the quartiles, quartile 1, quartile 2, the lower limit, the upper limit, and any outliers if there are any. So this will be your homework. I will end here and I'll require you to basically show me the workings for all these computations. I'll give you these solutions and I'll ask you to do them with the workings. That's what I need. So Thank you so much for your time. And I expect you to be in on Tuesday.